So today we'll be talking about surviving a ransomware and by leveraging cloud services. And I do have a colleague who is watching over the chat. So as you have questions throughout the time, Dave Richardson may respond and provide some links and other assistance during the presentation. All right, so our agenda for today, I'll start the conversation with just a high-level overview of what ransomware is. If you've paid attention to the news at all in the last several months, you've heard several examples of ransomware and what's happening, around us with regards to that. We'll talk a little bit about the NIST cybersecurity framework and how you can leverage it to build a comprehensive ransomware strategy. And I'll highlight a few of the recent documents that they've released to provide guidance to organizations. We'll then talk about how to go about strategically prioritizing, the security implementations and investments that you focus on. When you look at a framework, you may identify 50, 60 security controls, and then the question is, which ones are the most important? Where do I start? And so I'll provide some thoughts on that answer. Then we'll jump into looking at how AWS can provide some of the security capabilities that the risk framework identifies, and introduce you to a white paper for further information. And then we'll finish the conversation with a self-assessment security tool that you can use to validate the security of your AWS hosted environments. And then we'll open it up for question and answer. I've intentionally built this presentation to last about 40 minutes with the hope that we have some great questions and dialogue at the end. Please do be prepared for questions as we'll jump into that, and look forward to our discussion here. All right, so let's start with a basic understanding of what is ransomware. So when you think about it, really it boils down to a threat actor attempting to or gaining unauthorized access into a system, identifying data within that system, and then encrypting it to prevent the legitimate users from having access. They do this by encrypting the data, holding those decryption keys private, and then demanding the payment of a ransom in order to release that key so that the organization could restore their data. Now, the next step to that is, if you fail to pay the ransom, then there's a risk to the organization that you might permanently lose that data. And this is why we talk about having a comprehensive backup and disaster recovery strategy, and ensuring that the ability to restore is so important. So that in the event of a ransomware attack, you have the ability to restore that mission critical data. Now, the interesting thing is that this was kind of the original ransomware kind of attack pattern, if you will, for the first several years. And what they realized is that as organizations got better at backup and recovery, and the number of times that a victim organization paid the ransom was going down, they modified their tactics to then start adding on to that, and by that they would then begin exfiltrating the data or copying the data that they got outside of the organization. And if an entity had regulated data or sensitive data, they would threaten to make it public, potentially causing the victim organization to have to pay regulatory fines and things like that. So now it's not only access to the data itself, but it's also the threat of that sensitive data being made public as an additional emphasis for an organization to pay the ransom. All right, so when you think about the method of attack, you've got the typical happy end user who has a laptop or a PC computer and a local hard drive. And more often than not, the method of attack is focused on that end user. And that's why symposiums like this are so important. And typically that looks like one of three things. Either it's an email-based threat to where end users in your organization receive an email with a malicious link to a website that's been compromised, or it may be an attachment where they've said, hey, there's a really important invoice or document that you need to read, see the attachment. And when the end user opens that attachment, it then infects malware into their PC. Or it could be as simple as, hey, the help desk needs to re-enable your account. And if you don't respond now, you're going to lose access to this important system. And the end user is expected to respond with sensitive information like their username, password, or other data. Could be, end users out, surfing around on the internet, end up on a site that has been compromised, and kind of that drive-by malware infection is another way. Or as we've seen, not necessarily this year, but in recent years, to where large organizations, their database of usernames and passwords were compromised, and then those were published out on the internet for other folks to leverage, with the idea or understanding that many users will use the same username and password for multiple systems. And so they'll get a list of usernames and passwords and attempt to leverage those and use it to gain access to other systems. On the other end of the spectrum is your servers within your organization. And although we've been talking about this for many years, these issues still exist, to where some servers are not fully patched. There are challenges around implementing a patch management strategy. Some applications are mission critical or are third-party solutions, and it's very difficult to patch them and bring the systems down. That same issue of stolen credentials can be leveraged to access an organization's applications. Or it could be just a miscellaneous configuration error that exposed or opened up access in an unintended way. Those being the most likely way that phishing takes hold into an organization. Once that malware gets a foothold, then it starts to look across the network, maybe coming in through the internet. It's looking for additional workstations, PCs, servers, file servers. It may look for network attached storage, a database here, and even look for backups. And its intent is to scan and kind of traverse across the network infrastructure, looking for additional victims to where it can find the data and encrypt it, and ultimately impact the ability for an organization to operate. Important piece here too is, and I'll come back to this later through the conversation, but a lot of times organizations didn't think about or ensure that they had appropriate security controls and isolation of their backups themselves. And we've seen many organizations that, while they had a backup in place, the backups themselves were encrypted with ransomware, preventing an easy restore for the organization. Some other important information just in terms of the size of the problem. According to the Verizon Data Breach Investigations Report for 2021, last year, educational institutions suffered over 800 security incidents, and 228 of those were considered breaches. The difference being that a breach indicates that the bad guy had unauthorized access to data. Whereas an incident may just be a denial of service attack or something, but they didn't necessarily have data level access at the record level. And in the public sector, which would be your state agencies, local governments, and things like that, there were almost 7,000 incidents reported last year, 346 of those being a breach. Within all of those incidents, malware is a common attack vector, viruses and Trojans and things like that. And over all industries, ransomware was 27% of malware-based incidents. But in particular, in education and in public sector, it was a much higher percentage. Educational institutions, it was actually 80% of all malware incidents was related to ransomware. And in the public sector, it was 61%. And those numbers have grown year over year the last several years. Within education, 157 publicly reported incidents occurred last year, representing 20% of all security incidents, and 2,652 in the public sector were directly related to ransomware. And then, kind of the last interesting statistic, and, depending on which report you look at, these numbers are calculated differently, but the average impact of dealing with a ransomware incident was around $732,000, according to this one report. And as I noted earlier, tactics are shifting now to not only focus on the ransom for restoring the data, but also the threat of a public disclosure, especially for those regulated workloads where there's healthcare data or credit card information or other regulatory compliance things like CGIS or IRS 1075 or whatever the case might be. Right. So now that we've kind of defined the problem, how can we start to think about putting together a strategic plan and risk mitigation strategy around ransomware? And I would recommend, most organizations develop or identify a particular risk framework. It may be the ISO 27001 for international organizations, but most federal and state governments, you leverage NIST, whether it's the 800-53 or the NIST Cybersecurity Framework. Here I'll focus on the NIST Cybersecurity Framework. And if you've looked at that, they essentially break the security controls down into one of 5 categories, where you want to ensure that you have capabilities to be able to do each of these kind of topics, whether it's the ability to identify, to protect, to detect, respond, or recover. And you'll see a number after each of these. Those are kind of indicates the number of subdomains of capability that an organization would want to implement. In total, the NIST Cybersecurity Framework outlines 108 different outcome-based security activities that an organization would, seek to build capabilities around to ensure a comprehensive security program. And last year in July, NIST released a supplemental document that leverages the cybersecurity framework, NIST 1800-11, that focused on how do you recover from a ransomware event. And then in December of last year, they released 2 additional guides, 1800-25 and 1800-26, that deal with identify and protect against ransomware and detect and respond. Collectively, what these 3 documents do is it demonstrates how you can take commercial products that are readily available to buy from the marketplace and integrate them together to achieve a set of technical capabilities that you would need to accomplish, whether it's the recovery, the detection, the protection, that objective. And they provide a mapping of specific controls to the cybersecurity framework within these documents. Then earlier this year, with the most recent version being released in August, they released the NIST Incident Response 8374 Risk Management Framework, which kind of summarizes the 3 documents above in terms of the control mapping and the capabilities that an organization would need, and then provides an overview of kind of the risk management perspective. Now, in the 3 documents, the 1800 series, they talk about a concept called technical capabilities. And this is really where, kind of the rubber meets the road in terms of when I think about implementing a security strategy, I think about investing in tools and solutions. These are kind of the 11 categories that they group the capabilities into. So first is inventory. So this is the idea that in any organization or in any IT environment, you have to know what servers and applications and workstations and devices that you have in your environment so that you know to protect them. So asset management, configuration management, asset discovery, all of those capabilities is an important part of a cohesive and comprehensive ransomware strategy. Then they talk about vulnerability management. And so this is the idea that now that I know I've got all of these servers and laptops and devices, how do I routinely assess the security posture of those devices, make sure that they're properly configured, make sure that they're patched, and that they meet security best practice. And so that's really what that capability intends to do. Next, they talk about policy enforcement. So this is the idea that you may have organizational policies that say things like all of our network attached storage, data in that must be encrypted. at rest. It must only be sent using encrypted protocols. End users are expected to change passwords on this frequency. They're expected to use multi-factor authentication for systems that have this data classification. So this is do you have the technical capabilities and tooling in place to enforce those policies that your organization has established? Then they transition into integrity monitoring. How do you even know if you have data that has been modified by an unauthorized individual? Do you have things like cryptographic signatures that you can validate as checksums and ensure the integrity of data over time? And how do you monitor that? Then they transition into things like logging and baselining. What does normal activity look like for a system? What do you normally see in the log files? Are you capturing log files, and how comprehensive do you have a view of your environment? Do you just have some operating system logs, but you don't have visibility into actual database queries, or are you logging even at the database level and application level throughout your environment? Then they talk about backup and disaster recovery, and we spoke about that a little bit earlier. But obviously, this is really important. The goal in in ransomware risk mitigation would be to prevent a ransomware attack, but you're not always going to be 100% able to do so. So in those cases where your prevention techniques, failed to stop an attack, you at least want to be able to recover back the data that may have been encrypted. So you have to make sure that you've got, sufficient backup and recovery procedures and run books, that you've tested them, and so there's controls around that capability. Then there's the secure storage component. So this is the importance of how do I prevent against a ransomware attack actually exfiltrating my data, potentially causing that public disclosure. And so this is where encryption can be leveraged to encrypt that data, so that even if the bad guy gets it, their ability to publicly disclose it in clear text, such that it would create a breach of unauthorized access to sensitive data, isn't possible. But this is also around, spoke about, your backup tapes. If you're backing up to disk or even to tape, how do you make sure that the storage that is used there is isolated and protected from unauthorized access? Are you using a different authentication mechanism and security controls to ensure that only a limited subset of folks are able to get to the backups themselves, or to the storage with the on your network? I have seen customer examples to where the Active Directory environment in their organization was compromised as part of a ransomware attack, and those same Active Directory credentials were used, for the server that managed the backups. And so, the bad guy was able to get in and affect the backups themselves. Next, they transition into the network protection conversation. And so this is the traditional, do you have firewalls in place, intrusion detection, intrusion prevention systems? Are you doing inline threat intelligence type capabilities? And how are you ensuring that the traffic that comes in and goes out of your network has been filtered and assessed, using security tools? Deny listing is the next capability. So if I have a threat intelligence capability and I have a list of known malicious domains or IP addresses, or even file attachments, do I have the technology and the capability in place to prevent my end users from going there? And does that capability extend to them working remotely from home? Think about that, especially through the pandemic here, is, we've invested a lot of money and infrastructure into on-premise capabilities, but when our workforce is shifted to home and mobile, remote work, do we have the same level of protections in place to enable those customers or those end users? Corruption testing. So how do I make sure that my backups and those things are pristine, that they're able to be recovered, and that they will appropriately allow us to restore in the moment of need? And then the last is really around virtual infrastructure. And the idea here is that organizations, when they suffer a ransomware attack, if they are forced to basically rebuild their data center and start from scratch, having to do that with physical infrastructure, buying servers and storage and those things versus the ability to more quickly spin up virtual infrastructure and VMs and VM host capabilities allows an organization to be much faster, or to leverage the cloud to where you don't even have to stand up the infrastructure. It's available as a service, with a matter of a few clicks, can be a differentiator in terms of the speed with which you can recover your business. So the NIST documents talk about these technical capabilities. And if you're like me, it sounds like, wow, that's 11 different categories, and there's probably, there's definitely multiple controls under each of those in different capabilities and requirements. So how do I think about prioritizing these? So the NIST Incident Response Guide 8374 provides some guidance here, and I think it makes a lot of sense. So if you look at kind of that initial diagram that we spoke about how end users and or unpatched systems are the two most common ways that an organization would be, would initially be impacted by a ransomware attack, then NIST offers a list of basic preventative steps that if you're not doing these few things very well, you should start with these before you try and do the rest of the controls that they've identified. Don't boil the ocean. This list of curated, there's 8 things that I'll show you in the next slide, but these have the most return on investment. They're the most effective security controls for preventing ransomware. Then once you've established that capability and you've improved the maturity of those 8 key things, then start to transition to look at, how do I improve the backup and recovery capability to ensure that I have the ability to restore to a known good state? How do I improve the effectiveness of my protections and identification capabilities through, better inventory of assets, better vulnerability management, improvements in tools, things like that. And then finally, to improve the detection and response capabilities. But this kind of prioritized approach is what NIST recommends, and it at least resonates with me on the surface based on my experience. So those 8 preventative steps that are recommended, first, if you don't have antivirus installed and it's not updating its definitions on all of your end devices, that's definitely one of the first things, is that if malware makes it to your system and you've got antivirus that can appropriately detect and prevent it from executing, that's a great control. Obviously, the second here is patching your infrastructure, ensuring that all of the latest security patches are pushed out to your devices and servers. You only want to allow authorized applications. You know, you'll see, especially as you think about your workforce working from home, sometimes using personally owned devices, and you really don't have good visibility and or control into the software that they install and whether or not those might have malware embedded. You want to think about restricting what applications are allowed to be installed and by whom. And I know it's a tough conversation around not giving your end users administrative access to the operating system, but it is a very effective control to prevent this type of an attack. The ability to block access to ransomware sites. So a lot of organizations are leveraging DNS capabilities, things like Cisco Umbrella or OpenDNS or other DNS filtering solutions, to where that threat intelligence of, hey, this is a known IP address or a known domain that has ransomware or malware, prevent our end users from going there, is a very effective approach. The other thing I would say here is that having a robust capability for your end users to report phishing emails and suspicious emails, and having the capability to review that and leverage the data, links and things in there, and feeding that back into your email filtering capabilities is a great best practice. You want to use standard accounts whenever you can. So you only log in as administrator or supervisor or root when you absolutely need to do a particular function. Otherwise, you should only be logged in as just a normal user, leveraging that principle of least privilege. Restricting personally owned devices. Again, here the idea is the sites and the activities of a personally owned device, may create additional risk to the organization. Whereas, you on a work-owned device where you have a better controls and better agents and things like that, can mitigate risk. Again, avoid using personal applications on work devices if that's possible. And the obvious thing here, don't open files or click on links from unknown folks, is that tends to create a bad day. So these are the basic preventative steps that NIST outlines as, the first few things. Make sure that you've got a handle on these, and it will serve to reduce the likelihood of ransomware significantly with just these. So that's kind of the prescriptive or my suggested guidance in terms of building a strategy. So then transition the conversation to how can AWS help me with this, and how can I leverage the cloud? So what I want to first do is kind of introduce you to a white paper that I had the privilege to help author and publish recently. And it's basically building a ransomware risk management strategy on AWS using this NIST cybersecurity framework. And Dave will be providing the link here in the chat for you to go download this. But essentially what it does is everything that we've just talked about in terms of the NIST guidance, the incident response framework that they've published, and all of the capabilities that I just kind of reviewed at a high level, as well as the prioritization of those basic preventative steps, is included in this document. And then what it goes on to do is for each technical capability, we provide a mapping of the cybersecurity framework controls to the capabilities, and then a list of the AWS services that you can use along with descriptions and whether or not that that capability is included in our GovCloud region. So it gives you kind of a step-by-step, okay, I'm interested in working on backup. What services could I use in AWS or in the cloud to achieve that outcome? And then we provide a link to each of those services. So what that looks like across the 11 services we spoke about, you'll see here essentially that in each category, there are multiple solutions and different ways that you could achieve the same outcome, or a combination of cloud-based services that you can integrate together that together provide the complete solution, but they individually they may only have part of the capability that you would need. So for backup and disaster recovery, one of the most popular solutions that's a very elegant solution, and personally one of my favorites, is our Cloud Endure disaster recovery capability, which essentially allows you to install an agent in your servers, and it will provide asynchronous replication to a cloud staging environment, and gives you the ability to achieve a very low RTO and RPO at a very affordable price. For customers that are already running workloads in the cloud, we also have other capabilities around things like our elastic block storage snapshots, AWS backups, and also think about things like your source code. If you're doing a lot of custom development, do you have backups and the ability to do versioning of your source code repositories and things like that? And we have a service around that called Code Commit. For corruption testing, we've got a service called AWS Config and Config Rule that allows you to essentially have a complete history and visibility into the changes that occurred in your environment. Because the cloud works with APIs and all API calls are recorded, you have the visibility to dive in and say what user made what change at what time to this server. Because yesterday it was working, today it's not, and it provides complete visibility and auditability of the environment. Wouldn't it be nice to be able to do that in the traditional data center? Systems Manager also provides capabilities there. And then as you look across all of these other categories, around deny listing, we've got managed firewall capabilities, the ability to do web application firewalls, network access control lists, You can use our network firewall to do intrusion detection capabilities. We have Amazon Guard Duty, which is a threat intelligence platform. From a forensics perspective, we also have a service called Amazon Detective that helps your security operations center and incident responders dig into the root cause of a potential finding and understand the events that led to that. So, for each of those kind of capabilities, we've got a full complement of capabilities and services that can help there, and extend that on out to integrity monitoring, inventory logging, mitigation and containment, and network protection. In each of these categories, we've got multiple services and solutions that fit together to provide a robust set of tooling. And really, I think the beauty here of this is when you think about the challenge of your IT organizations today, and especially around security, it's hard to recruit all of the security talent that you would want. It's hard to keep them and retain the talent over time. And when you have those challenges, and then you combine that with the traditional approach of buying best of breed services and solutions, and then spending time in the procurement process once you've procured it, in the installation and configuration process, and then really figuring out how to integrate all of those tools into a cohesive, logging and monitoring environment can be challenging. And then when one of those vendors upgrades or changes a data feed format, then you essentially have to go back and re-architect and re-engineer your security tooling. And so in that normal strategy, it can be difficult to make traction, especially around implementing all of these different distributed services and tools around security. The value proposition that the cloud can provide is all of these are integrated into a platform. They're built using standard API technology. And all of these services that we've highlighted here are built to work together. So the amount of time to procure and build and configure and integrate and all of that really it eliminates almost all of that undifferentiated heavy lifting. So a tremendous value in terms of establishing, building, and maintaining a comprehensive set of security tools. All right, so the last thing I wanted to address before we jump into questions here is, okay, great, I get it. We want to, we'll investigate standing up an AWS, or a cloud-based architecture, but this is new to us, and I'm concerned or have questions about how do I make sure that what we build in the cloud is secure. And so what I wanted to introduce you to here was an AWS self-service security assessment tool. And really what this intends to do is to help you answer that. How can I proactively know that what I build in the cloud, when I set up an account and I deploy resources, how can I make sure that they're secured appropriately? So in addition to your normal tools, think, vulnerability scanning tools like Nessus or Rapid7 or whatever tools you're using, what we've done here is released an open source tool that is easily deployed into an AWS account. When you run this tool, it results in about $1 of cost. And once the tool has completed its assessment, it self-terminates and essentially leaves the resources or the reports behind for you to assess. It's a GitHub-based solution, so it's open source and free to download. The only cost associated with it is just the utility of the compute infrastructure that I'll show you in the next slide. And so what we do here is when a customer uses this tool within their AWS environment, we create an isolated virtual private cloud, which is essentially your private network, or private data center, if you will, inside of the AWS environment. We create a public subnet and a private subnet. In the private subnet, we spin up a EC2 instance. In this case, it's an M5A, which just refers to the size in terms of the number of CPUs and memory that the server has. And we also create a network address translation gateway so that server can reach out to the internet to download a couple open source tools. And then we also create an S3 bucket, which is our object storage. And that's created so that the results of these tools are then stored so that you can review them. We leverage two open source cloud security assessment tools, one called Scout Suite and one called Prowler. Both of these essentially do a series of different API calls to validate the configuration of your AWS environment and the resources that have been deployed. And so this is going to do those checks of things like, is there a password policy enabled? Are you requiring multi-factor authentication? Do you have encryption enabled into your S3 bucket? Is that public? Does that S3 bucket allow public access? And there's hundreds of checks that these two tools will do. In addition to that, there are a set of additional security assessment checks that we wanted to enable specifically around ransomware. And so we've written custom modules that integrate into this solution that will automatically check for best practice and configuration around specific ransomware capabilities or preventions. And all of the results of those are then dropped into that S3 bucket. Typically within about 30 minutes is what it takes for the assessment to run. And then, as I mentioned, all of the infrastructure that we dynamically provisioned is eliminated or deleted for you, with the exception of the S3 bucket, where we keep the logs from that assessment for you to be able to review and take action on. So, in closing here, as you think about the strategy that I spoke about in terms of focus on the preventative steps first, and then look at recovery, identification, and protection, and then detection, kind of in that order. You may say, well, are there additional resources and some security best practices or guidance on how I would engage in those next steps and kind of get more details about what the cloud would look like there? What this slide here is basically showing is a couple really important resources that I would recommend as kind of the next steps. One would be the top 5 protections and recovery, preparation actions. Then the self-assessment tool that we just spoke about in terms of, leveraging that. We do have a really comprehensive white paper on how to build an incident response guide and build in the capability to detect and respond there. And then if you're looking for a summary, kind of executive level of just overall ransomware strategy and the cloud, we do have an ebook that I would recommend as a resource to review. So with that, I do want to say thank you for the opportunity to talk with the group here today, and want to open it up to questions.
Thank you, James. A reminder to the audience there to put your questions in the chat, and we have one already here. Regarding the security assessment tool, how often do you recommend this being run within an AWS account?
Yeah, so that's a great question. Thanks for that. So what I would recommend, especially for an agency or an organization that is opening up or creating an AWS account for the first time, I would recommend that you go through and follow the security reference architecture, which is another white paper that we have in terms of best practices for configuring the account. And once you've done all of that initial configuration, then I would recommend using this tool to validate that all of the best practices have been implemented, and use it as a validation or assurance type step to ensure that all of the knobs have been turned and levers have been pulled, as a precaution before you put any kind of important workloads out there. And then the second thing I would recommend is then do that on some routine frequency, whether it's after you've deployed a new workload and you've made changes to the environment. Run this again to just ensure that those configurations didn't change, or that it didn't have an unintended configuration change that opened up access to more than you wanted. So I would recommend running it on some frequency for kind of a drift detection type strategy.
Thank you. And while we're waiting for we do have another question here. We've looked into AWS as a replacement for our on-site servers, but found it prohibitively expensive. Is there any government pricing that reduces cost?
Yeah, so what I would say is, I think one of the underlying assumptions here that you make when you look at a migrating workload is that I'm going to run my application in the cloud just like I do on-prem and do a, what we would call lift and shift to where it's one-to-one. And while in some cases that can be more expensive, especially when you factor in licensing and some things like that, the real value proposition in the cloud is the ability to leverage elasticity. And when you start to look at provisioning based on what you need now, and then having the ability to scale that up and scale it down, and do that over the traditional life cycle of 3 years or 5-year refresh for your infrastructure, most customers end up saving 30-40% in the cloud workload, but it does require a different thought process and a different way of operating. But a great example, in a lot of state customers, when you think about elections, you may only need that application a couple days a year to support the election cycle. And in the traditional on-premise environment, you would spin that up and provision it and leave it up for the entire time, because you've bought physical boxes and capabilities. Whereas if in the cloud, you're able to spin that up for a couple days and then spin it down. Or think about your development and test environments, where you may only be doing development Monday through Friday from 8 to 5, or testing, and as you're building applications. And if you have the ability to spin that infrastructure down in a utility-based model, there can be substantial cost savings there for a customer. So part of this is the ability to right size the infrastructure, and provision and deprovision as needed is really part of the value proposition. And you have to kind of look at, how do I change the way I run my IT, and support my workloads, is the kind of the cost savings opportunity.
Thank you, James. While I'm waiting for more questions from the audience, I have a question here. Are you able to share a real customer example of how they benefited from using the cloud?
Yeah, sure. Especially within the, I'm assuming within the ransomware context. So I personally helped a customer in a different state, who was running a traditional on-premise infrastructure, and they had an application where they wanted to implement stronger password management and multi-factor authentication, but it was a challenge politically, and they were not able to get approval to do that. And an end user's username and password was essentially used to gain access into the environment. The bad guy was then able to basically deploy ransomware. It impacted their entire infrastructure, including their Active Directory and their backups. And so the use case here was, and I kind of alluded to it earlier, this customer realized that essentially their entire data center was compromised, and they were at the point to where they had to start from scratch. So as they looked at options, one option was to basically buy a bunch of new equipment through their normal procurement, wait for it to be shipped, rack and stack the equipment, start to configure operating systems and reinstall applications, and then try and recover what data they could from developer laptops that were working on, had sample, older copies of databases and things like that as part of their development effort. What they ended up realizing was that there were supply chain issues with even buying hardware, and uncertainty about how soon they would be able to get the hardware. Um, so they looked to AWS and said, well, how can you help us? We were able to basically help them provision cloud-based infrastructure, and begin restoring their mission critical applications. And essentially, within 3 or 4 days, they had their most mission critical application back up and running in the cloud. And then over a series of 3 or 4 weeks, we helped them restore all of their other applications. And they essentially have gone all in on AWS, to where their entire infrastructure is running now in the cloud. And I forget the exact percentage, but somewhere around for 40%, at a 40% cost savings versus what they were paying for on-premise. After we help them essentially re-architect. So that's that's one good example. of how customer could benefit from the cloud in a ransomware scenario.
Thank you, James. As I've been scouring the chat here for questions, I noticed that Dave Richardson has been putting up all of the links that you've talked about as we've been going along. So I want to point that out to our audience there, that the chat is full of the links that we've talked about. While waiting for any additional questions from the audience there, you talked about backups being important quite a bit there. Are there any specific best practices that you'd recommend?
Yeah, so I think the key thing here for an organization is to talk about kind of what your recovery time objective and recovery point objectives are for your business. And not every application has the same risk profile. And that's one of the challenges with a traditional backup infrastructure, is that you kind of build and buy a solution to your highest requirement, and that can end up being fairly expensive when not every workload really needs that. So I would say really understanding if this application or this system had a security incident and we lost data as a result of it, how much data could we afford to lose without it being impacting to the mission of the organization? Once you understand that, then you want to build a backup and recovery strategy that recognizes those requirements, and work towards that. And I think the key thing here as it relates to ransomware is two things. One, you want to make sure that those backups that you do perform are saved in an environment that is isolated from your production network, and where the point of compromise may happen, so that the backups themselves are secured. And you want to limit access and permissions using probably a different authentication and permissioning model to that environment, such that if your primary Active Directory or other means of authentication into the environment were compromised as part of this, that they couldn't use those same credentials and access methods to get to the backups. And then the other thing is, you also want to make sure that you're creating enough restore points and restoring it or maintaining enough backups to where, if you didn't discover the ransomware attack, or the malware sitting in your environment for a period of time, that you're able to recover back 15 days or 30 days or 45 days, and that you've got a good archival strategy, such that those backups are still available, versus overriding your tapes every 2 weeks or whatever your retention cycle is. So I would say those are some key best practices here. And then the last one would be, you really want to make sure that you've developed a run book, so that the sequence in which you do recovery steps. You know how to get applications reinstalled. You know where the license files are for those applications, and you've tested the step-by-step kind of sequence of restoring, and the dependencies and all of those things, so that when there's an actual event, that you're not figuring that out for the first time, and you have higher level of confidence that you can indeed restore it.